All right, so here's our calendar. Next Friday will be a quiz. We'll talk about the quiz on Wednesday, what's going to be on it. It will be a multiple choice quiz. It will be a multiple choice quiz. All right, so once again, your homework is a worksheet, and we're going to do similar triangles again. So practice day, practice day. Same two objectives. Like I said, there's no difference now in the slides. So I started off by saying it's a tough day. It's somewhat new information. Some of you may have never done similar shapes before, but for those of you that did, it should be a review. And then I started talking about what we did in the previous classes. Well, the previous classes we were doing Pythagorean theorem, so we were dealing with right triangles. But in the classes before that, we dealt with acute, and we also dealt with obtuse triangles. So the new idea is this, imagine any shape, right? And in PowerPoint, if we draw a triangle, we click on it, we can make that triangle larger or smaller simply by dragging one of the corners. And these two triangles that I made, the small one and the large one, they look alike, just one is bigger than the other. Okay, and in math terms, we call this similarity or similarness. Okay? So the definition of similar figures are two figures that are exactly the same shape. They're just different sizes. One has been enlarged or one has been reduced. Okay, but the proportions of that shape have not changed. Okay, so we say that things are proportional. Okay? So if we start off with a small triangle, ABC, and we make it larger, we've got to call it something new, DEF, we can say that those two triangles are similar as long as I've maintained some proportionality. Now we have a symbol for similar, not an equal sign, not a congruent sign, but we have the one little wiggle there, a tilde, and that's the mathematical symbol for when two things are similar. So when two shapes are similar, you're allowed to say that they are similar using that symbol. So for instance, triangle ABC is similar to DEF. Now, recall that when things are equal, that means literally the left side is the right side or the same value. When things are not equal, right, we use an inequality. That means the left side and the right side are not the same value. And then lastly, we have this symbol called the congruency symbol. It's generally used with shapes. When shapes are, two different, I've got a red one and a blue one. When they're two separate shapes, but they have the same measurements, that's when we use the congruency. So when the left side has the same value, I know this is somewhat challenging to understand the differences between equality and congruence. They have, some sameness to it. So for instance, if we're talking about two sides of two different triangles, when those sides have the same value, they're both 9 inches long, we can say that those two sides of two different triangles are congruent. Okay, and that's when we use that. And then lastly, today we're talking about similar. Similar means is that there's something, well, not to use the same word in the definition, but there's something similar about the two shapes. Okay? All right, so it turns out for similar figures that there's two main consequences. Well, the first consequence is that the corresponding angles of the two shapes. So that means the side or the angles that match up to one another. Okay, so if we're talking about the top angle and the top angle, as long as they're in the same orientation, we call those corresponding angles. So for the consequence when two things are similar is that their corresponding angles are congruent. So now I have these two triangles. I didn't twist them, turn them, or anything. Unfortunately for you tonight for homework, they'll be twisted and turned. But if they have the same orientation, if A goes with D, if C goes with F, if B goes with E, we're talking angles there, then those are the corresponding angles. We can get those two different ways, like identifying which ones are corresponding. We can either visually go with the picture, okay? But sometimes this is challenging because you got to twist and turn them in your brain. We can also go by the similarity statement. I like going by the similarity statement. And the way the similarity statement is written is the way that the angles correspond. So A is the first letter on the first triangle, D is the first letter on the second triangle. So A goes with D, B goes with E, and C goes with F. So we could say that angle A is congruent to angle D. Now look at the two triangles. A and D are two separate angles. But when their measurements are the same, we say they are congruent. That's why we're using the congruency symbol. And there are the other corresponding angles. The issue comes when I take one of those triangles and flip it over and then rotate it a few turns, okay? So sometimes you really got to do some work in order to match the two shapes up visually so that they have the same orientation, so they look like these two. Okay, they're easy once they're oriented the same way to match them up. Top goes with top, left goes with left, right goes with right. But for most of the examples we'll have tonight for homework, they've been twisted and turned. Okay. All right. So the first game we have is I'll give you two similar triangles. Notice I've twisted one of them, and I also give you a similarity statement. And I will give you two angle measurements. You have to come up with the third. So for instance, I may give you these two angle measurements. The measurement, that's what the little m means. The measurement of angle A is 60 degrees. The measurement of angle C is 70 degrees. And then I will ask you about a third angle. I want you to find the measurement of angle 3 or calculate it. So the first thing you can do is you can label which one you're trying to find. I'm trying to find angle E. How big is angle E? And then label what you know. I know angle A is 60, and angle A corresponds with angle D. I'm getting that from the similarity statement. A is the first letter, D is the first letter. So A goes with D. So if A is 60, then D must be 60. Okay. Angle C is 60, and angle C corresponds with angle F. So, I'm sorry, I did B next. B goes with E, right? And I don't know what that one was. That didn't get me anywhere. And C goes with F, and we know that C is 70, so therefore F is 70. You see the logic in that? To find the third one, we use this other bit of knowledge that we already have, which is that if we have any triangle, and we add up the three interior angles, the triangle has three of them, we will always get 180 degrees. So how do you find the third one? You add the two that you're given, and then you subtract it from 180. So the measurement of angle E is 180 minus the sum of the two that were given, 60 and 70. Do that math. 60 plus 70 is 130, and 130 subtracted from 180 is 50 degrees, and that's how that one's done. Yeah, that's a big woo because that's a lot of work. When they've been twisted or turned, sometimes going by the similarity statement is the easiest method to use. So, once again, I will give you two angles and ask you for the third one. Just be careful. Do this process exactly what I'm showing you. We know that we're given angle A. Let's see, an angle A by the similarity statement goes with D. I'm trying to find F. So let's see, A corresponds to D, so therefore D is 40 as well too. We can label that. B goes with E, and B is 50, therefore E is 50. And then lastly, C goes with F, and I don't know what either one of those is. But I do know that D is 40 and E is 50. So I take the sum of those two, 40 plus 50, add them together, and subtract them from 180. The sum of the three interior angles of a triangle add up to 180 degrees. 40 plus 50 is 90. 180 minus 90 is 90. So F is 90. Make sense? Remember the little M there means measure, the measurement. All right. We did this yesterday on the Google Forms. If you want to do it again, you can. If not, just try to get to the answer or at least the process before I do. So let's see. I'm given that these two triangles are similar, and I'm given these two bits of information, and we want to find E. So let's see. How do we find E? Well, we're given A. Or E is the one we're looking for. Let's see. A goes with D. So therefore, if A is 65, D is 65. We're given angle C. We're also asked to find angle E. Well, E goes with B. I don't know what any one of those are, but I do know that C goes with F, and C is 55, therefore F is 55. There are the two angles that I'm given on the triangle that I'm looking for. We add 65 and 55. That would be 120. And from 180, we subtract the 120, and therefore we get 60. Make sense? Okay. One more. Now, don't get in the habit of just adding to those two and subtracting from 180. Sometimes it's like that, but other times it might be slightly different. You never know. Just go through this process. Let's see. We're given angle A. We're trying to find angle C. So put a question mark there. Let's see. A is 40. I can label that. E is 55. E goes with B, right? And B is 55. Okay. And C goes with F, and I don't know what that is. Okay. However, I do know that if I add those two and subtract from 180, I get to my answer. So 40 and 55, that's going to give me what? 95, and 180 minus 95 is 85. There we go. Now, sometimes they get a little bit more complicated. This is a triangle within a triangle. But we're going to do it exactly the same method. The reason why the measurement of those angles there are listed with 3 letters is because it's more descriptive. So for instance, if I say angle D, you're like, well, which one is it? The one on the left or the one on the right? There's actually 3 angles there. Using angle ABC and AD is a bit more descriptive, and it shows us where we need to go. So let's see how this one is done. Well, we're given that angle A is 15 degrees, so I can label that. Visually, I can see that AED and ACB are both 90 degrees. So technically, I have 2 angles at each triangle. I can find the third. So for instance, if I'm looking to find angle ABC, trace that. ABC, now you see which angle it is? Well, let's see. I've got 2 of those angles of the larger triangle there. A is 15, C is 90. So I do 90 plus 15, that's 105. And 180 minus 105 is 75 degrees. Okay? We do the same thing with the smaller triangle. We got 9, it's the same numbers, so therefore we're going to get the same answers. Or you could notice that angle B corresponds with angle D, the middle letter with the middle letter there of the similarity statement. Either way works. So that's how you handle one of those triangles within a triangle. Got it? So that's the first consequence, done with the first consequence. The second consequence is, well, I said this is the tough part. And generally, this is where students have the most issues, is that the side lengths of similar shapes are, well, they form a proportion. They are proportional. So here's what that means. That means take any side of the small triangle, for instance, AB. Well, it corresponds and it's proportional to another side. So its corresponding side is proportional. Well, which side corresponds with AB? Well, I can either, because I have these 2 triangles oriented exactly the same way, or I can look at the similarity statement. AB is the first 2 letters, so it would correspond to the first 2 letters of the second triangle. So that would give me AB and DE. They are corresponding. Let's look at BC, the bottom part of the small triangle. BC would correspond with EF, and the last one, CA, would correspond with FD. Now here is the thing to remember. Because they correspond and that the 2 shapes are similar, we get this proportion. So check it out. Look at the top, the numerator of all 3 of those ratios right there. Those are 3 sides of the small triangle. And all I'm doing is I'm putting one of the sides of the small triangle over one of the sides of the large triangle. But the 2 that I'm picking are the corresponding parts. So for instance, AB corresponds to DE. So I get AB over DE. Well, that would be equal to BC over EF, which would be equal to CA over FD. In other words, I'm making ratio of corresponding parts, and all 3 ratios are equal to each other. Now, when they look like that, it's no big deal, and most students have no issues. The difference is I'm going to twist and turn these things. So you just have to be really careful and make sure you're matching up the same parts. So here's one where I haven't twisted or turned anything. I just got a large triangle and a small triangle. So if you need steps, here's how it goes. Well, you make a proportion. That means a fraction equal to another fraction, or a ratio equal to another ratio. Now, you look at, one side is missing. That's the side, that's the x. Well, which side of the smaller triangle corresponds with x? That's 8. Right? Can you see how those match up? So x goes with 8, so I put x over 8. Then I go back to the large triangle, because that's the one I started with. That's on the top. And you pick either one of the sides, 18 or 15. I always choose the smaller number, so I'm going to choose 15, and which side corresponds with that on the smaller? It's 5, so we put 15 over 5. And then we simply do some cross multiplication to solve that. 5 times x is equal to 15 times 8, okay, or 8 times 15, either way. We do the algebra on that, we solve the problem, and we get to the answer. Not an issue when the shapes haven't been twisted or turned. So here's another one where they haven't been twisted or turned. So once again, the steps are find the side you're looking for. I'm looking for x. X is on the large one. Which side on the small one corresponds with x? That's 3. Really easy to do because visually they're oriented. The 2 triangles are in exactly the same position. Go back to the large one because that's the one we started with. Go back to the large one and you pick either side, 12 or 6. Always pick the small one if you can. Which side corresponds with 6? That's 2. So we write 6 over 2. Does that make sense? And then we simply cross multiply. 2 times x is equal to 3 times 6, or 6 times 3. Okay. Therefore, x is equal to 9. I'm doing this rather quickly because remember, this is just a repeat of what we did on Wednesday. It becomes more challenging when things have been turned. Now notice, can you do this in your mind's eye? If we turn the larger triangle, right, if we just rotate it counterclockwise, it will not look like the small one. That's because one of these triangles has been flipped as well. So not only do you have to turn the large one a quarter turn, you got to flip it. Okay. In other words, 12 goes with 2, the 30 goes with 5, and the x goes with 4. You got that? That's the hardest part about this process, is being able to match them up. Okay. So once again, x is on the large one, and x goes with 4. We go back to the large one. We can pick either 12 or 30. I always pick the small one. Well, 12 goes with 2. Therefore, 12 over 2. I cross multiply to find out what x is. 2 times x is equal to 4 times 12. Okay, solve that, and we're done. All right, yesterday I made the comment that some smarty pants people can probably just look at the numbers and figure out, hey, it's been doubled, tripled. It's not always the case, and here's one that where it's not the case. Now notice, all we'd have to do, and since we're only given 2 sides, right, this one's pretty easy to twist in your head. You know, well, how do you know that this one hasn't been flipped around? Well, if it's been flipped around, we can't solve it because all we have are 2 numbers there. So this one has not been flipped around. All right, all it's been, one of the triangles has simply been turned 90 degrees. So let's see, we're trying to find x. X would go with 11, okay? And let's see, I started with a small one, so I go back to the small one, 3 goes with 4. Now notice what I said there, the order does matter. So if you start with a large one and you put that in the numerator, all the numbers for the large one have to be in the numerator, and the denominator has to be the smaller of the two. And you can go either way. If you want to start with the small one and go to the large one, that's fine. Or start with the large one, go to the small one, that's fine as well too. For me, I always start with wherever the x is, the variable. Okay? All right, so that would give me what? 4 times x is equal to 3 times 11. This one's going to be an ugly answer, but it's still okay. The process is okay. All right, this one right here. Let's see. If you flip this around, this one wouldn't matter because look, it's an isosceles triangle, so both sides are 7. So that one's pretty easy to match up in your head. Okay. So let's see. I'm going to go from large to small because the large has the x. So x, that would be x over 3. And 49, because I started with the large one, 49 over 7. Okay, make sense? So 7x is equal to 3 times 49. Do a little bit of math. And 7 goes into 147 21 times. Okay. Okay, so I ran through that rather quickly. You do have this video to use as help for doing your homework. If you have any questions on it, don't hesitate. I've had a couple people ask for some Zoom conferences so I can give you some one-on-one help. That's perfectly fine. Make use of that. If you want to make use of email, that's fine as well too. So you guys have a good weekend. Do your homework, and I will see you on Monday.